So if you're at home, you missed me talking about all that. You're probably not watching anyways. Let's do one that actually matters. This one has transformations.
It goes
Right to?
right to and up
Up forward. You need to be catching on to that kind of stuff, kids. Right to, up forward. It's not hard. I've been doing it since absolute value. You might be thinking that we're just not going to have enough room to graph this one. We are, because it's leading with a negative symbol. It's not actually going to start high. That went up too far. Fix that second. It's not actually going to start high. It's going to start low. It's leading with a negative symbol. Yeah, it's a reflection. Technically, it's decay. It's decay that's been reflected. All right, now, as far as your table goes, there's your center. And you don't put 2, 4 in it. The Y value is not a guarantee of these because you're not actually centered here. You're centered on the X value, not the Y value. And I would just kind of go back to units, maybe 1 and 0 and 4 to 3 and 4. I know I do a lot of stuff up here, but you can type stuff in calculator and use the storage feature. Okay, I know you can do that. But if you plug in a 2, which is the easy one to plug in, you'd have 3/4 to the 0, which is 1, times -3, which is -3, plus 4, which is 1. Plug in a 1, you would have the negative first power. 3/4 of the negative first power is 4/3. Times the -3 is -4, plus 4 is 0. If you plug in a 0, you'd have the -2. That is going to be 16/9. Times a -3 is -16/3. Add 4. I think you're at -1/3. Yeah, -16/3 plus 4 should be -1/3. You plug in a 3 or the first power, -3 times 3/4 is -9/4. You add 4, you're at 1 3/4. Plug in 4, you're squaring it, it's 9/16. So -27/16. 37/16 is right. Which is what, 2 5/16? You check with TI-84, kids, use storage feature. Okay? That's all I'm doing is plugging a number. You get that, right? This ain't magic. Not magic, just math. So there's your table. To the right, 1, up nothing. To the right, 2, up 1. To the right, 3, up 1 3/4. To the right, 4, up 2 5/16. Zero is -1/3. Not kind of looking the way I hoped it would look. I'd hoped it would level off more.
Let's go up more.
Well, it's going to. No, there's nothing wrong with what we wrote. I mean, it's not going to cross that thing. There's some curvature being shown. There's some curvature. Well, if you plug in a 5, I just don't feel like doing it. It's going to look like, I missed the points, but it's going to look like that. That's what it has to look like. It cannot cross that horizontal line, can it? No, it's got to have the same overall shape as all these slopes and decays, which is a curve. So it's got to look like that to some degree. What's its domain? Okay, that's the easy one. What's the range? -4. Horizontal asymptote? Y equals 4. Thank you for saying Y equals. I say Y equals. 4 is wrong. All right, so hopefully that's all the graphing we're doing. 11 minutes left. Negative pay to positive infinity. You actually have this formula in your notes from yesterday. That is exponential decay. The difference is we don't add in the rate of growth, we subtract the rate of growth. Yep. A sub t is still the amount after time passes. What's P still going to stand for? Principal. What's principal mean to you? It's the initial amount. Initial amount that you have. R is still right here. It's rate of decay. And T is still what? Time. Oh, look, kids do funny things. Kids will plug in R for T, and kids do funny things when it comes to this stuff. I really don't know what those formulas is. I've seen kids measure time in grams before on a problem. Only a cokehead measures time in grams. Only a cokehead. And that kid wasn't a cokehead yet. Let's see. Your great-great-grandfather left you $2 million. But it's in a poorly managed mutual fund. You gain access to the funds this year. Problem is the fund lost 32% of its value every 3 years. Write a model. All right. What's the initial amount? $2 million. Sounds nice, doesn't it? Amount of time passes is $2 million. You're thinking, oh, I'm going to be rich. You're still going to have some money. You are. We don't say 1 plus, we say 1 minus. Now, we have to express 32% as a decimal. Anna, what is 32% as a decimal? You have to know. 32% as a decimal. You have to know. How many places you shift it? 2. 32% as a decimal. That's me. Chandler, 32% is a decimal. 1, 3, 2. To the left. We're done. 1, 2. We can't just say T. Time happens how often here? Every 3, per 3, over 3. But we're not going to do B. I don't like that. I'm telling you, the only reason I can talk about this is because 3 OC is older than me. It's hard with rounds. That's what it does. Not accurate. Let's just do C. How much money did you receive this year from your great-grandfather? Well, it's 2021, right?
12 years.
12 years have passed. So the amount after 12 years is going to be this 2 million. 1 minus 0.32 is 0.68. 12 over 3, which is 4. Yeah, of course you can. Isn't that 12 over 3 is? But, you know, kids miss stuff like that. 12 years, 2021, right? Great-grandfather left you this money in 2009. So this year is going to be the 12th year. No, you still get a good chunk of change. You're just not as rich as you thought you were. Then you're going to have to pay taxes. Well, you may or may not have to pay taxes on that. Yeah. If you don't know what 12 over 3 is, no worries. If your calculator requires parentheses, use them. This one doesn't, but I'm showing them anyways. Yep. $427,000, $427,627.52. So you're still getting good money. Are you really gonna be mad about it?
That's $400,000 you didn't have.
$500,000 you didn't have. That's a slightly used combine.
Or if you buy what you kind of.
No, I'd run my old piece of crap that was built in '88 and I'd buy land. Who's this question about? No, it ain't Palmersville. Palmersville don't have 3,200 people. This is Dresden. Dying town with no industry and very little offer its youth, has a population of 3,200, which increases by 15% every 4 years. And we're going to skip over B. Part A is to write a model describing the town's population. Go ahead, Happy. Ace of T is? Wait, 3. Parentheses. Forward. No. The model here is a principal, 1 minus R to the T. That's kind of the default model. So 1 minus what? 0.15. Sure, 1 minus 0.15. What are we going to raise this thing to? T over 4. That's good, Happy. That makes me happy. I don't really feel like cleaning this up. I don't. I don't want to move that 1/4 in. C is, when's the population of the town going to be 1,400? That equals, right? The amount after time becomes 1,400. We are going to have to graph this thing. It'll be a couple of days before I show you how to do this by hand. There is a way to do this stuff by hand. Where's 1,400 go? About Y1? Where's this stuff go? Y2. We're going to have to be on the lookout for this thing. Now, some of y'all's calculators is going to require parentheses on that T over 4. If it rooftops and it doesn't throw in the exponential space, you have to use parentheses. Have to. This last question in your notes? Good. I thought they were short. How high are you going to want to look? At least 1,400, right? I'll look up to 1,600. 10 years isn't going to do it. I'm going to try 100. So I'm setting X max to 100, Y max to 16. And what we're going to see is this thing's going to come in from up high, right? You can. It's going to come in from up high. No, we got 100 definitely did. Turns out Dresden doesn't have much life left in it. Second trace 5, which you ought to be comfortable with by now. And you know, mine was fairly close from the get-go. I'm just going to press enter 3 times. 20.35 years. No, there'll be lots of people here still. The town did shrink for a while, but it's kind of sad what happened. They moved all this support offices into Dresden, and people started moving in because it's close to the support offices. The population started growing again. That's what happened. Anyways, pretty much, you know, if you need help with anything, they're here. There you go, kids. That is 7.2.
But
It's not hard. Hard doesn't happen until we start talking about logarithms. Start talking about